Hello, welcome to the final edition of our workflow. Up to now, we have designed a simple axial fan blade. We went through some initial analysis. Then, for a more realistic analysis, we meshed our model, and then we did execute a CFD model. In this step, we're going to take a look at the results using CFD post. And I'm not going to go into a lot of detail on how to use CFD post. I'm going to more focus on the specialized TurboSystem tools to make turbo machinery post-processing easier. So for that, we loaded our results. We're going to go hit turbo. We're going to initialize all components and then hit calculate velocity components. So now we have these kind of shortcuts to get quick results for turbo machinery related solutions. One key thing I like to look at is look at blade to blade view of the flow, because a lot of times when you design a blade, you don't want flow separation around your rotor blades, or if you have stator blades. So the way to do it is we click blade to blade. We're going to look at the mid span. We're going to look at our velocity. Let's do local velocity. Now what I would like to do is maybe add at least 2 instances, because we modeled only one of the 30 fan blades, and we're going to hit apply. This is very quickly going to get us the right view, without any user input, the velocity field. And what we quickly see is there really is no big separation region. It would have showed up as a big blue region. So that is good news. It's a good design. Another way to look at it is right now we're looking at contours. We can switch to a vector view. Let's hit apply, and this is going to put vectors on each cell. And again, let's see. So we want to maybe change the sampling. Let's do equally spaced points. Maybe 100 is not enough. Let's make it 1,000. Okay. And then, for example, zoom in to the flow field, and we really don't see any recirculation zones, so that's good. And we can go back to our original view, go back to our contour, apply. So default is to show pressure, and what I wanted to see is, again, go back to velocity, do local, and I do want to save a picture this time. So now we're looking at some velocity contours. If I decide I like this view, I'm going to go hit the figure button and insert a figure now named figure 1. All right, and you can generate any type of vector contour plot using these options. So if I go back to turbo, we're going to get back to our view. There are also some turbo macros, which I'm not going to go into. But what I'd like to go into is the report viewer. So if I click on the report viewer, this is a very quick way to generate reports out of a CFX or a Fluent model. And this particular one is fine-tuned for a fan solution, but you can add and delete components. It can have the physics report, the boundary definitions, and you can add results. For example, I saved figure 1, so it is now showing up under user data chapter. Uh, and if we were to go to more detail, if we go to outline, for example, if you go under report, here you can edit your title page. You know, you can turn on and off. If you don't want to give mesh information, you know, you can untick those. You have control over the contents of the report here. So going back to Turbo, another key piece of information we want is, as a designer, it's blade loading. Blade loading is essentially the pressure load on the pressure and the suction side of your airfoil. So here, and you know, the area between the two is it's the work, it gives you the work. So larger, it's doing more work, and one can quickly look at, you know, at different spans. For example, let's go near the shroud around 90%. I'll hit apply, and then we see slightly different blade loading. Or near the hub section, you know, we go around 10%, hit apply, and we can see our blade loading chart. So designer may look at these and you know, decides to make certain changes on the geometry. This is very helpful. And what's also nice is if we go to report viewer, if we hit refresh, and we're gonna see that, you know, the chart added to our report. So this concludes our presentation on how to post-process a turbo machinery CFD model.